Consider it punched. Hello.
It's punched.
Hey,
Chewy
Ben,
punched
how are you?
the hyperdrive, and we're now hyperdriving through the interwebs.
I'm trying to think. You know, I'm an old science fiction fan, and I'm trying to think all the different ways they described going faster than light in all the various science fiction.
Yeah, actually, one of my favorite descriptions in a book of that was a really, really obscure book by a guy who switched away from science fiction, probably because his first two books were science fiction, and I loved them. However, they didn't really gain traction, and then he went and started writing books, historical fiction about medieval Europe, and particular England, Scotland, and Ireland.
Okay.
But the book was called Empyrean by Stephen R. Lawhead, and they travel through a wormhole to a distant star. And it's an interesting concept because, you know, they describe the warping of everything around them, and this guy basically pukes on his chest because he was told by the pilot of the spacecraft to keep his eyes shut during the jump.
Right.
Because you can't cope with what you see when you're traveling faster than light.
Right. Yeah, and that's a recurring thing. Yeah.
He couldn't resist the temptation to have a look, so he looked sideways and everything was getting smeared, and it made him vomit.
Right. And there's some science fiction stories where the way to survive going faster in light is you have to surround yourself with life. So they put like oysters between the hulls of the ship. I mean, you know, there's just, it's been
weird. There's a lot of weird. Yeah. Another one that was really good was Isaac Asimov's. One of my favorite Asimov stories is The End of Eternity. I think it's called The End of Eternity, something along those lines. It's a really great story. It's not a particularly long one either. You can read it pretty quickly.
Yeah. Oh, I grew up with Asimov. Yeah.
It deals with it's really good. It's really good deep thought sort of book because it deals with what are the things you have to what are the psychological and emotional problems that would arise if we could time travel.
Right.
So that one's not about traveling faster than light, but it is about time travel. So
right.
Yeah. Anyway, as you can see, people, I'm not in my office today. I made a faux pas. I got to my office like 15 or 10 minutes ago and realized I didn't have my keys to get into it. So I had to race back home and quickly just jump on the laptop. So I apologize for not having my fancy LED sign behind me, but I'm pretty sure it doesn't even matter.
Right. Well, so today I got in a new toy. Let me see if I can show it. And
that is cool.
This is a preheater, a dedicated preheater, and I didn't even need it so far today. Here is my infrared desoldering machine. So
did you just get that, or?
I got the preheater today. I got this today.
Yeah.
Or this week. But I've had this a while. But I had a problem where I went to do some desoldering for somebody and I got my ass kicked. And today I'm sitting here popping stuff off the boards willy-nilly. Hang on, let me go back, change cameras a second. So I've been sitting here popping parts off of motherboards today willy-nilly, and I know they're lead-free, so so I don't know why I was having problems, but we're going to pull more parts off today. I figured just for fun. Yeah.
That is cool.
Let me get this started. So what's a good part? Ooh, let's...
Yeah, there's a question. Is that Jonathan Pallant's asking, is that an S478 motherboard?
So I got the motherboard from Thomas out of our Discord channel. Thank you very much, Thomas. He sent me a pile of these things. And what kind of motherboard is this? It's a mini PCIe 1394, blah, 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 blah.
Now I know what happened to all the missing C64s that people are trying to find again.
Right. The people are popping parts out of it. This is an STC.
15 years ago, before retro computing was a thing, people were using them for desoldering practice.
Yeah.
And now they wish they hadn't. They wish they'd kept them.
Oh, I sold prototype 128s to somebody that just needed a C64.
I even had, 286 motherboards that I'm like, dang, I wish I hadn't thrown that out in the garbage collection.
Right.
Because it'd be fun to put a 286 together again now. And it would actually be a cool thing to do. But whatever.
Yeah, Curious Mark did a restart. So right now the board is on the preheater. So I have a ceramic preheater, and I'm bringing it up to 200 degrees C while we're talking. Curious Mark did a restore on an IBM Model 60 or something, which to me would not have been retro, but now it is, right? You wait long enough, and we grew up with.
This raises an interesting point. I'm a member of another Discord for content creators, which you are too, Bill.
Right. I want to catch one of those.
Actually, speaking of Discord, I better open it up in case people are chatting in there. And one of them wrote a really fantastic news article. I'll just find the link for it. So if anyone's interested in reading, let me grab the link. Copy link. And I'll post it in the comments. There's the link in the comments. And I'll also throw it on a banner. Give me 1 second here. It's kind of a long link, so the banner's probably not going to be useful, but there it is anyway. But there's this fascinating article that IBM threatening to sue this company. There's a European company that actually has a really brilliant software product that is needed. It's needed. Okay. Some of these systems, particularly banks, are still using really old mainframes and old systems that are getting more and more expensive and hard to maintain because the parts they're old. And I think back to when we had our chat with Usagi Electric,
right,
and restoring the old mini computer from 1980 or 78, or he has parts. Some of the parts of his computer were built in the late 70s. Some parts were as late as 1980. But just getting the things to get something going again. Now that's a hobby project, and it's really fascinating. And this is a big deal. But if the big institutions that have big legal departments like IBM start going and suing people for reproducing essentially what amounts to virtual machines.
Right.
So what this company called LZ Labs was doing was they recognized a lot of banks and other big companies that need reliable systems that have kept the same mainframe hardware running for 30 years.
Right.
And they still use it, and it's still doing its job, but now they're running into problems with maintenance. So that the very clever idea is, well, that's okay. We can emulate that whole system in a virtual machine now. Of course we can. And that's the point. And so IBM comes along and tries to threaten and flex and use big legal departments to say, no, you can't do that. That's our IP. Right. I guess in one hand you could say yes, if it's their own instruction set architecture, which it probably is. In theory, technically, you can't copy the instruction set architecture without infringing IP. But it's very, very debatable. But the other side of it is, that's one side. The other side is your customers have software they need to run.
Right.
And if you provide them a machine that will interpret their software and actually execute it, that doesn't necessarily mean you've copied or reverse engineered somebody else's instruction set architecture. Yeah, there's some gray area in there, of course. And I know other people who are much better at software than me would know more about it. People like Johan, people like Jonathan. Hi, Jonathan. I know you're on today. But it's like, no, these people run critical systems, and they're dealing with billions of dollars of all of our money. We must allow them to find a solution to keep things running on newer hardware. So, and basically, it looked like IBM wasn't going to win. But it raises, to me, it raised this whole question for our community. Part of what we do and our hobbies and our enthusiasm and our lust for life comes from figuring out how these things work. And if there's this constant legal threat that just by figuring out how something works, someone's going to, fine you or whatever, or take you to court and cause financial harm to you when you're just trying to figure out how something works, definitely not okay. Definitely not okay in my mind. So, hey, you just got a BGA off that thing.
Yeah, I just did.
You know what the real test is of rework, desoldering? The real test is you can take the chip off, you can clean it up, you can reball it, and you can solder it back on, and it still functions.
Right. Which people do. There is a whole DIY out there for like PlayStation 3s and Blackpad. They're trying to cure the Blackpad, where they know it or not on some of these.
Right.
So what is Blackpad?
I don't know. You tell me. Corrosion.
Oh, which one?
Corrosion between a VGA ball and the copper on the board.
Wasn't there cobalt involved, or was it copper?
I don't know. It's some kind of corrosion, but it's to do with the metallurgy,
right?
And processes back in the 90s of assembly. Actually, later than 90s, because wasn't it? Well, didn't Blackpad come up with the Xbox Gen 1?
Yes, I believe
that's
so.
right. It was the Xbox.
It's not an old problem. Yeah, it's still around.
So we're talking 2009, 2010 timeframe that it kind of reared its ugly head. Well, it's things that were assembled in 2009 and 10 that several years later got Blackpad. Yeah.
All right. So what I'm going to do is I'm going to flux another part. So I have heavy duty flux paste for doing this, and I'll just take off a surface mount part here. And I'll throw this back on the preheater while we're talking. The good news is I don't have to worry about ruining the board.
Right, because the heat, that's the value of an infrared station, because the heat is concentrated just where you need it.
Right.
So how does it generate the infrared light in there? Does it have a big incandescent light bulb with a reflector and a lens?
It does. Yeah. So typically you'll also use these, but I found that if I make the hole too small, I don't get enough heating around it, enough,
Right, but you can make an aperture just for that part.
Right.
Then you have a trick getting the part out through the aperture with your tweezers.
It's the same trick of getting it off quickly, because you have to move it out from under it, and you have to get it while it's still fluid. Yeah.
That's cool.
Mylar stencil. Actually, Mylar stencil.
Oh, yes. That was Chip Quick, I thought, actually had those, and you could buy them.
There you go.
You could buy them. They were like they were pre-cut Mylar or Kapton.
Yeah.
And you could peel them off the backing and stick them down onto the board, and they would effectively add a thick layer over the BGA land pattern. You could squeegee solder paste into it, put a new BGA down on top, and use the infrared, and the film would stay there under the part, but it would have extra thick balls.
Oh, okay.
I remember Stencil Quick. That was the one. Yeah.
Okay.
Yeah, I remember those.
Right. So I just happen to have I think I got this through DigiKey Proto Advantage.
Jonathan, I love that comment. You lost an iBook because the Radeon would desolder itself. How did they let it get that hot? Wow.
Yeah,
And they wouldn't fix you up in it looks like they wouldn't they wouldn't give you another motherboard after it kept doing it. That's not good. That's not looking after customers. Yeah, I like that little screen that shields you. That's kind of like what the dentists use.
Yeah, I'm already blind from looking at it. Oh, my chip's already off. Already that quick, I'm done.
That's so bright.
Yeah.
Can you actually see what you're doing under all that light?
I'm actually blind now from staring. So normally I wear sunglasses while doing this, but I couldn't find them.
Yes.
Oh, I actually have a Hackaday article using this. Let me post that to the comments here. See if it lets me.
How much did this cost you, by the way?
It's your typical overseas $100, $200 type thing. It's
that's not bad at all. Not bad.
It might be 300, but I don't think so.
Yeah. I don't do a lot of repairs with surface mount parts, so I'm happy just sticking with the hot air gun for now on my I have a hot air rework station, and
right.
It does the job. It's more prone. It's harder to use hot air and not damage parts.
Well,
but I had training with hot air rework some years ago by an IPC certified trainer, and I learned how to do it. So I've had pretty good success with that so far.
Right. So that's a great segue, though, for preheating.
Yeah.
Get my little piece of, and there's people that say hot air. Check out Zeftronics.com for a BGA rework stations that's done professionally, and they believe in hot air because the profile simulates the actual profile of when you made the board. It's not shocking the board with 700 degrees suddenly. So,
yeah.
But this is not a hot air heater. This is a ceramic element preheater.
Oh.
And so this could work with your hot air. In fact, I've seen them where you slide your hot air over it and you're preheating the bottom and hot airing the top.
Yep.
And preheat's really useful when you have heavy copper, 2-ounce copper, or multiple layers of
yes. Recently I had to actually do final assembly work on a short prototype run of some boards, and they had a lot of copper through, and they were only 4-layer boards, but they had a lot of copper fills, but they were very thin. The board designer, I didn't do the board design. It was a very well designed board, but the board designer used his normal process, which resulted in a thin board that had no thermal release on the through-hole pads of the other parts, and I had to get some connectors and things soldered onto it to do bench testing of the prototype. And man, it was difficult. It was so difficult. And I have a very high-powered workstation. And I put a massive big tip on it, and it was still really hard to get a good, what I appreciate as a good solder joint where it flows right through the hole and there's nice wetting and fillets, all because it went thermal release. So preheating would have helped with that.
Yeah.
But I don't have a preheater, so.
And the other day when I failed to get the part off I was after, I believe I was skipping a good thorough preheat. I think I got myself in a hurry. The other thing is to actually measure your temperatures, which I've got my old-fashioned. These things are great.
Oh yeah, the Thermocouple.
Yeah, simple tool.
And even a good DMM. So I have one of the Dave Jones EEV blog.
Oh, cool.
I have a spare which was intended for a giveaway, and we will use that for a giveaway for our viewers. So stay tuned.
Right.
But one of the Bryman, the nice little Bryman with the EEV blog blue case, and so that one actually comes with a Thermocouple as well, and a heat-proof capped on tape sort of cable to it. So you can stick it on a board under some capped on and put it in the in the oven or under the hot air if you want.
Yeah.
So the other one that people love to show off is their FLIR thermal cameras, but they're horrendously expensive even now. It's like, damn, why are they so expensive?
You know, I should show that next time. This isn't mine, but where to go? Oh, there it is. This is an iPhone adapter, iPad adapter.
I've seen those. Yeah, that's the FLIR phone camera.
Yes, it is.
They're still like $400 or something.
Yes, they are.
That's a lot.
Yeah.
I can't bring myself to spend that money on that when I should rather, you know, keep saving towards a better oscilloscope or something.
Well, at the end of the day, I still get my hard numbers off of here, even though I use the FLIR to see what's hot, and I use it to see relative heats, right? Did they get hot?
That's the value of a thermal camera. You can see where it's really coming from.
Right. And you know, you see a via heating up, you know something's wrong or something, right? But there's still nothing wrong with the good old, and the only thing is I have it taped to, we call these orange sticks or orange wood or something. And so I can stick it in and probe it. But here's when you're a serious Kapton tape user, is when you've got an actual dispenser roll going here.
That is serious. Jonathan was mentioning never understood how thermocouples work. Do you want to give us a rundown?
What's the name of the voltage that's created by the two metals touching each other? I sold thermocouples. I did a Hackaday article, and then on herdware.com, there's a thing on thermocouples, and I linked all the documentation. But it comes out that there's a voltage generated by the two metals when it's not galvanic. Is it Peltier? I can't remember.
Well, there's two different ways, and I believe a thermocouple doesn't use the Peltier effect. I think
it's the other one.
But you can measure temperature with a Peltier effect because it will generate electricity from, like a DC battery. It'll generate current from a thermal difference from one side of the Peltier element to the other. But the Peltier element itself is a particular kind of silicon device, whereas a thermocouple, to your point, Bill, is just two dissimilar metals touching at a point, and it varies resistance with temperature, was my understanding.
And that's what I thought, but I think it actually generates a voltage, because if you get your thermocouple backwards, it won't read right. So I'm still looking for what is it the Seebeck effect?
Seebeck, yeah. Seth said Seebeck, Chris Georgie, Seebeck effect.
Electromotive force between, so right. I believe that's what it is. And they're common thermocouples like the type J's and type K's is what I had a little board that used to amplify those.
Yeah, I appreciate the sentiments. Yes, I'm feeling much better. I actually was sick, and then 2 weeks later had a cracked tooth and had to have my tooth extracted 2 weeks after that. So yeah, it's been brutal, but I'm much better now. Thank you for asking.
So here's actually a thermocouple amplifier I made using my little 2-inch by 2-inch outline. So it's got a precision op amp to measure the effect, and then it's got basically the cold temperature reference built into it. So
that's cool.
Yeah, because you need to compare it to ambient to get an accurate reading, is my memory. It's been way too long. So yeah, I was selling these for a while. I don't even know why it's on the bench. Hey, here's something I found but forgot to show last 2 weeks. I found a 4-inch wafer laying around the place. This is, and somebody asked about RAMs. I'll talk about Commodore RAMs. This is, I don't know if you can read it. This is a 27C32, 23C32. This was to Don Black, who worked at Valley Forge, who's somebody I know.
Yeah, that's out of focus, but
yeah, okay. Sorry. Yeah, it's hard to read anyways too. So
better 23. So that means it's mask programmed wrong. It's actually got.
That's CMOS ROM. Yeah.
Did you throw it under the microscope to see if you could find any?
I didn't. My bench is so full today, I didn't, but I can certainly do that on one of our follow-ups here.
Yeah, we should do that. It's always fun throwing silicon under a microscope.
Right. So, Commodore, somebody asked about RAMs, and so I assume they mean DRAMs. We never made a static RAM. We tried to get into the DRAM in the NMOS days, and we bought Micron's processes, my memory, and then had problems rolling it out. We had problems with the pattern generation and the way the polygon set. And I don't know where we went with that, but I never designed in a Commodore RAM just because the industry was changing so fast and the people that were good at it were really good at it. And Commodore wasn't just yet, you know? Yeah,
it makes sense because that's not long after, you know, that's how things tend to go with any kind of business. It's both the, how do we put it? It's both the blessing and the curse of a technology company is specialization, right?
Right,
so
right.
At the beginning of a technology, if you have chosen to really just focus on that one thing and be the best at it, you can totally dominate. And that's what, you know, in this book that Altium's CEO had all of Altium's management read some years ago, and it was a really good book. It was called Good to Great.
Right.
Many people have read it.
Right.
And in that book, it's called Finding Your Hedgehog Concept and Your Flywheel. And they say that the hedgehog is a really obscure little creature, and it doesn't really do much, but it does one thing really well, and that's just roll into a ball and set the spikes out whenever it's under threat. And so it basically has no predators. But besides that, it lives a very simple life. It doesn't do much. It's not really fancy. It's not fast. It's not agile. It just wanders around, lives in a hole in the ground.
Right.
But it does its one thing, which is roll into a ball and set the spikes out. It does that one thing really, really well. And so they call that your hedgehog concept. And so, you know, this book came around Altium because at the time, the CEO who ousted the founder of the company wanted to basically cut off all the embedded, all the FPGA. And you've heard me whine about that before because I joined the company for those things, but whatever. Right. I believed, I was one of the true believers that you could have one really good CAD tool that did all your electronics design and was able to seamlessly synchronize between them. So if you wanted to do a pin swap on the board, it would automatically update your C header files for your GPIOs, for example, right? That's how things should work. Anyway.
So Daniel mentioned Asianometry, which is an excellent YouTube series. And yes, they have a show just about the DRAM Japanese DRAM vendors of the 80s, NEC, Hitachi, and those. And it was really cool. It actually, it was nostalgic for me to watch that one episode.
So, but this reminds me of the whole Intel story. Intel saw themselves as a RAM and DRAM company, and the reason they grew and survived was they're like, no, we can't be good at this. We need to stop trying to be good at this and figure out what we are good at. And that turned out to be the microprocessor. And look at them now, you know, so.
Right. So I have two Intel RAM stories. The first is, again, I'm from the late 70s, early 80s, bubble memory. They did a big bubble memory push. They came around and did seminars and stuff, and I remember going to a couple. And bubble memory was where they had bubbles of magnetic domain, and they would bucket brigade them around on a chip. So you would wait for these shifts to come around, and then you would get like 256 bits in a row. And they're doing
so that's not MBM though, right?
What's MBM?
Magnetic bubble memory. IBM used to do that.
Yeah, it probably is.
It was horrendously expensive, not particularly dense, but it apparently had some weird advantages over regular static RAM or dynamic RAM.
There was no flash. It was flash.
Yeah, I think it was partly non-volatile. So it was it would eventually lose the data after so many minutes or hours of being unpowered, but it would, yeah. And so that was used in high rel systems like brake controllers for aircraft or whatever. But yeah, not very dense though. You didn't get a lot.
Not compared to like just 3 years later where we had, you know, it was changing so fast that bubble memory was obsolete before we got around to thinking of bubble memory, you know?
Yes, yes.
So
someone was saying
go ahead.
We're upset at my Motorola for not having carried on with the 68,000s. Of course they did. They spun them out. I agree. Like they made probably arguably the nicest processors, but remember that got spun out as Freescale, and they still have members of the family. They just didn't win for desktop computing. And bear in mind they do still make. So remember, the 68,000s gave way to Power architecture. Remember, PowerPC was launched in the late 90s, or mid 90s. They announced it. I think the first computers available using PowerPC, and even Commodore before they disintegrated, I believe, had some kind of. Maybe, actually, no. Sorry, I'm confused. It was Apple who adopted PowerPC first. Remember, so in the iMacs and the iBooks of the mid to late 90s were all Power architecture. Now, I don't know. Yeah, Chris says it's an IBM. It was actually a collaboration, oddly enough, between IBM, Freescale, or Motorola, and it was Motorola and one or two other companies. I forget the ones.
IBM and
Apple. But basically, that's still there. And so I know IBM still have Power architecture derivatives. Well, I believe they do. I know for certain Freescale, which is now NXP, which renamed themselves Nexperia, because, you know, why not spend millions of dollars updating all your letterhead? Why not? And all your websites. Keep the teams busy with something to do.
Yeah.
But they aren't used in any kind of desktop or consumer computer goods. The Power architecture is used a lot in automotive. So if you get into a really nice Audi or BMW and it's got this beautiful entertainment system with a big LCD screen and fancy animations and mapping and all that stuff,
right?
Guess what? That's running on most likely a Corriva part. And those Corriva parts are multi-core Power architecture. They're really, really powerful chips, but just, I don't know why, just, I guess the Intel and Intel compatible and ARM now just have so much momentum in consumer electronics. So,
yeah.
But they're still there.
So I remember going back to, you mentioned Intel wanted to be a DRAM, wanted to be a memory company. And I had books, big black books, Intel data books. They produced a DRAM with a floating substrate. And they were transparent about this. They said, we screwed up. They had this floating substrate. And if that sounds like a back bias generator, I'm thinking that's what it was. And they were well into their DRAM process. And they came across what they called the IBM pattern. And what they did was, if they wrote all ones but 1 0 to the chip, the substrate would basically move around and the 0 would flip to a 1. So they found they couldn't, and that was called the IBM pattern, where if you wrote all 1s and a 0, you got back all 1s. And it's because the substrate was unregulated, basically. And they got out of DRAMs. I remember 5 years later, there was no Intel DRAMs.
Yeah.
I was on the team. Kev was on what team? I wonder if he meant the Intel, the IBM, the Apple, the PowerPC. So. Oh, so you were talking about old science fiction writers that kind of were out of their genre at one point. I remember reading Edgar Rice Burroughs' Barsoom series. going, what the heck is this? This is cool.
Just because it was so different.
It was, yeah. I was way young, yeah.
Yeah.
So
yeah.
let's see, what else is-
711, you were on the team. Maybe you should jump on and tell us some stories about the 68,000 team. We'd love to hear some of those stories. Of course, there's always fear of litigation surrounded by this, but you know, if you're good at telling stories, there's no problem.
You want to try an invite in the comments tab? That shouldn't be too dangerous, because after we end the session, the invite is useless. Kevin, you want to join us? Kev,
yeah, Kev, why don't you jump on and tell us some of this, some of the, would you be interested?
So call this a social experiment.
Yes. So in the chat comments there.
My old computer is so old. Yes.
Good. Hang on to it, because remember the graph, the bathtub of value. At the beginning of an object's life, it's worth a lot, and then pretty soon afterwards, it appears to be worth nothing for a very, very long time. But if you keep it in good working condition, eventually, towards the end, it becomes worth something again.
Right.
The bathtub of value.
Except for
it applies to almost any motor vehicle, almost, because there are some that will never be worth anything, no matter what.
Right. Except for that 3 sigma point where your capacitors dry out. You have to go in and actually.
Well, yeah. Look, old cars as well. Like there's this thing in my town. I live in Escondido, California, and in Grand Avenue, Escondido, every Friday night throughout the summer. It's actually ending this. Probably today will be the last day for the year, because they end on the first holiday weekend. That's September. I forget the holiday, Labor Day, whatever it is. But all the people with old restored classic cars come out and drive them up and down the main street, and there's live music and people walking everywhere. It's pretty cool. But yeah, anything old takes maintenance, including you.
Right.
And me.
Right. Right. Yeah, the part of in your case, the part of your body designed to last the longest, your teeth. You know, I've had the same problem. I get old and my teeth are like the ones showing the wear.
And you must look after your teeth. So I think previous generations, and particularly in Australia, my parents and previous generations in Australia didn't understand this, but so much of the rest of your health is affected by your teeth. By
your teeth, yeah.
If you have bad teeth, you can't eat healthy food.
Yeah.
It hurts too much.
Now, did they have fluoride in Australia? In the water?
Yes, they did. They introduced that sometime right when I was a baby. And fortunately for me, it did not make my teeth go brown. But I have cousins and other friends my age who, because of the fluoride introduction, their teeth, and drinking tap water as babies, their teeth went dark brown here and there. Nasty.
Yeah, I've never heard that with the brown. Though I can imagine tap water with lots of metal ions in it. So.
Yeah.
All right. Let's see. Well, I feel almost like pulling more parts off. What else can we talk about here today? So.
Well, you had a technical question about Altium, but it was with a customer design, so we decided we couldn't really.
I'm not going to show it on the screen, yeah, but basically I hit a problem with the automation where if I generate a fabrication file myself, it's fine, but if I tell OutJob to generate it, it puts the drill holes in a place they've never even been before. It's not like it's an old version. It's a corrupted origin problem or something.
That sounds weird. So let me see if I can reproduce it with a design I can share on the screen.
I've had it not be a problem on all the designs before this, so I don't know if mine's got a bad piece of math in it, like the origin of a single drill or something.
Okay, I'm going to close this.
Yeah, show the out job thing. That'd be a good general purpose.
Yeah, this could take a little bit, but let me open an existing design for something that, I'll do this PBO2. Okay, so under settings, we have these things called output job files. So you're saying when you manually generate a drill drawing as a Gerber file, because the drill drawing is just a Gerber layer traditionally.
I generate the NC drill.
Oh, was it the NC drill?
Yeah, the NC drill had garbage in it compared to the rest of the circuit. Like it was misaligned, but it misaligned meaning like an old rev. But those holes were never there. I mean, these were big holes right in the middle of a land for a chip. I mean,
you need to go in here and check the configuration of your NC drill in the out job file and make sure this matches.
Sure. Matches how I manually generate.
Match the units first. So in my case, I'll do millimeters, 4 leading, 3 trailing. And the origin is a big deal. If you're going to generate Gerbers and NC drills and have them match up correctly in a CAM input, you want to make sure that the reference is identical. So relative origin means if you change the origin within your board design, and you often will want to do this, you want a floating origin that you can move around to different things because it just makes it easier to precisely place things.
Right.
But when generating outputs, I pretty much always make sure everything's referenced back to absolute. But that can be a problem too if you've imported a board design from somewhere else, or if you didn't pay attention to the origin when you started it. The corner of your board, or whatever the datum is that marks the 0 point of your PCB layout, may be way off in deep space.
Right.
And so I'm always very disciplined about when I'm starting a board design, I always start with a particular feature of the board that I know I'm going to use as a datum in my documentation.
Which is usually it's a corner for me.
Usually it's a hard corner if it's just a rectangular board, or it's a mounting hole, or a fiducial, and then I make that a fixed offset from the hard origin, and that's usually going to be a fixed offset that's enough to contain the whole board in the quadrant 1 of the workspace. So all my XY coordinates are positive and not too far out so that it's floating in deep space. Then when I come to configure my outputs, I'm referencing everything to the absolute origin.
Right.
But I've seen people do this and say, why is my Gerber, when I generate Gerbers, it shows up blank in the workspace? I'm like, because your board is at plus XY, it's at plus 138 inches, X and Y. Why is it so far away from the origin? You know, you've got to pull it back in. Seen that a lot.
Right.
But the point I'm making here is your drill files need to have the same format and reference as your Gerbers. And normally I don't use drill files anymore. Normally I just use ODB++ or IPC 25.
And the vendor didn't take ODB++. I asked,
Yep, so here I'm setting my Gerber settings to match. Millimeters, 4:3. Plot layers used on. Drill drawing. If you want to generate a drill drawing in Gerber, you have to.
I got one in the Draftsman.
You have to, normally I don't use Gerbers for documentation. That's again the old way of doing it.
That's the old way, right?
Draftsman is still a bit painful and still a bit half-baked and still quite buggy and very slow, but it does save time on documentation because it's much easier to make the documentation you want, and it has templates and all that stuff. So having to do that in Gerbers in the past, you'd have to manually draw tables and import things from Excel and try to copy and paste them in as text in a Gerber layer. And it just took a lot of work to make documentation layers in Altium to generate them on Gerbers in the past.
Right.
So here we are, I'm setting that to absolute. So now let's go to generate some files. And if I go ahead and generate content, this says released managed. What I really want to do is just run this locally. Normally, so I'm manually running all of these. Normally, what happens is you pre-configure all of this and then you run the release manager if you're using Altium 365 or Nexus or server or whatever. And it runs all of this according, like it uses this as the script and then bundles all that together and puts it there. If you want to, you can still run this locally, which is what I'm doing here by clicking generate content. So this ought to, this is going to take a while. It's usually a bit slow. I should have probably deselected most of those. Is that running? Yeah, it's running. So it's not responding to me. So that means it's thinking about it.
The out job thing, I've learned to just walk away from the computer.
Oh, here it goes.
If you change the focus, I've seen it actually change a schematic because I clicked on the schematic to open it while out job's working and it moved apart.
Mm-hmm. Yeah, well, I guess this is still running, generating all this. So the value of this is you preset everything and you can reuse an out job file with multiple projects. So you can configure, like if you're going to use Gerbers and NC drill and IPC D356 test point net list, you can preset all of that and say this is my normal setup, and you can apply that to every new PCB project you do, so it saves time.
Right.
In the configuration. You don't have to use out job files. You can just go to file.
There's a big
fabrication outputs. Gerbers, yeah. And now it's generated and now opening some of this stuff.
Which a problem I had is I referenced the BOM twice and it would try and open it twice with the same name and stop the whole process. I mean, it's just the things I found the hard way are.
So yeah, this is the basic default bill of materials where I've grouped things by part number or library reference. So all the 33 ohm 0402 resistors are grouped together. It's still, I don't know if you can, it's probably too small to see the icon down here on the taskbar, but this has still got a lot going on behind the scenes. Let me minimize the Excel so you can see what's happening here. It was zipping along with all these status bars a moment ago.
Right.
Yeah. So you're saying what you generated, your drill file from the out job did not match.
Right. The drill
file that you manually generated.
Yeah. Well. So I'll check the origin. I mean, that's how you set it up to begin with. So
it was actually showing the drill holes.
They were in the wrong
CAM
place.
editor. It wasn't. Not this. You're not talking about the drill drawing, which is your drill symbols.
Right. Not that. So when I read in smallroundholes.txt back into Altium, you could see it when you import it. They were in the wrong place.
That is
when you
truly
use a
bizarre.
Gerber viewer that shows you the drill layer. So the problem I had with Altium is I couldn't see the drills at the same time. There you go. So drill is not included on what you're seeing there, right?
Well, when it generates the Gerbers, to auto import the drills that go with it. So it's asking me to do that now, and
I don't recall.
it automatically is adopting the same units, 4, 3,
right?
absolute origin in inches. But if you want, you can modify the tool table and units.
Right.
But I'll just click OK because I know that they were set to match. Oh, this is the DRC. Oh, no, it's just a file format warning because this is a really old reference design. But all my drills, I see the drill holes. They're in the right places. That's this olivey green color.
Right.
Or gray green.
So how do you open just if you want to look at just the NC drill? I believe I did a file import on a text file. Can you do an import of the NC drill file?
The way I would do that, if I want to look at anything that's NC drill or Gerber or any kind of CAM data, that's in the editor that was previously known as Camtastic, which is why these files by default are still called Camtastic1.
Yeah.
So I would create a new CAM document from the file menu that's blank, and then the Camtastic panel appears, right? And then from there you go import, and you can use any of these. But if it's specifically a drill file you want to import, no, you can import Gerber's ODB++ IPC netlist, which is for the IPC netlist is really for test point and test information, but it's a format that basically contains the net list of the whole design and the location of test points. And if you import Gerber ODB, if you import Gerber's drills and a net list, you can actually reverse engineer the Gerber files into an actual PCB document.
Okay.
Because it has enough information to know where all the copper and pads and vias are. The only problem with it is it won't automatically create footprints from footprints. It'll treat them as individual separate pads. By default, you have to define a component by selecting the aperture flashes that define that component and say that's a component. Well, that's going to take you forever, right? So, especially if you have a big BGA on a board, you're not going to select each little dot in the Gerber and say this is a component. Ideally, we would want to create some automated way of figuring that out. But so anyway, this is basically how you do it. You can also import NC files for milling and routing.
Go ahead and import your NC drill file.
Yep. So let's set the folder. The default folder here sucks. So let me see if I can find it on quick access. No. Where did I put this?
Yeah, Altium's got a few initial file locations that don't use inheritance.
Yeah, in order to find where this should be, I'm going to right click on this one and go.
Do explore?
It's where the hell did that put the explore? Oh, I tell you what, because I haven't saved it yet. Let's go here and go explore. So I'm exploring the folder of where that is, and project outputs is where it puts everything for generation. So the drill file's in here, so I'm going to copy that path from Explorer, and back in my Camtastic file, I'm going to go import drill. I'm going to paste the path there, and then just click browse to double check that this is. Select the folder, and there it's found all the files that can be used to import drill data, including the DRR and also text files, which these are the actual NC drill Exelon format drill files. And it by default, you'll see there's a bunch here because this design has a panel for full-on panelization as well as part of it. So we'll ignore those, but the individual board has non-plated holes, plated through holes, and slots. Plated slots. And if I had non-plated slots, they would have their own drill file as well, just because that's how I've had it configured. So let's first start with
the most popular.
Yeah, plated round holes. Actually, I'll do all of them.
Okay.
Because you can group select and do everything. And it automatically detects the format from the headers in the files. And it gives me a little report. But once the report's in there, they all are.
Right, right.
And you can isolate things in here.
But now,
so there's plated slots.
Right. So how do you show those drills then on top of the Gerbers to make sure they're in the right place?
Well, you import them after the Gerbers have been loaded in here. See
Right.
how the same files are in here.
Right.
Right. So, but to make it really clear, let's remove silk screen. That's silk screen. Like, you can isolate things. There's the top layer. These are the inner negative plane layers. So these are solid copper ports for power and ground. There's the bottom layer. So let's just put top and bottom enabled. I'm using the arrow keys here to highlight these layers. And then over that, you enable the holes. And I have to, gosh, it's been so long since I've driven this. I'm showing my ineptitude here. Let's just, so we have, see this little red X on that layer? It's probably really hard to see. But the round holes plated layer is shown on top of everything else right now because it's the layer that's selected. So I can see I can see they're obviously all lined up, but sometimes you want the drill guide layer. The drill guide should give you little crosshairs where the drill points are. So the drill guide is a layer that's auto-generated to give the centroids of every hole.
Right.
And the color of that's not particularly bright. Let me make it white so everyone can see it real clear. All right, that's the drill guide. And I can put the drill guide on top over all the other layers as well. So,
all right.
Drill guide used to be needed because drill machines used to be set up manually by a drill machine operator who would run through a routine where they'd move the machine head with a camera and they'd be looking into a viewport or on a monitor, and they'd superimpose the drill guide layer over the actual board and the fiducials on the board and visually line up the master drill guide with a fiducial drill hole.
Right.
And then lock that in and then press go on the program and the drill machine would run, right? Of course, now people are not needed for all of that. All of this stuff is automated. So,
right. Very good. So, well, we're coming up at the top of the hour here.
Yeah.
So it's anything else that you can think of showing here today that won't take too long?
Well, just look at the comments and see.
So, yeah, somebody asked if there's a 3D view. It's important to understand we're in the Gerber viewer, which is 2D information. But yes, Altium has a 3D view of the board when you're in PCB layout mode.
Yeah, that's, let me open the board so you can see. So this is the board in 2D. So, and all the colors, by default, the CAM editor colors match the board layer editors, but they don't automatically do that. If you go and modify your layer colors to make your workspace happier for you, the CAM editor has its own set of color settings and it uses the same defaults, but they don't follow each other automatically. So,
isn't there several ways to color a net? It's like you can do it at the PC board level or at the schematic level, but you have to push them to each other.
Yeah, so this is just a little daughter card that was for an old FPGA development board that Altium used to make called the Nanoboard 2, which was totally awesome, I've got to say. And Dave Jones of EEV blog fame was one of the hardware engineers who designed these boards back in the day. And if you want to learn more about that, I actually was a guest with him on the Amp Hour about a month ago. I forget the episode number, but we had a lot of laughs. We were sharing old stories about how crazy Altium was back in the day before he went full time with the EV blog about 12 years ago. But I don't know if he designed this particular board, but he did some of the more difficult ones, like the actual FPGA motherboard. There was an 8-layer version, and they managed to get it down to 6 layers and lower the cost quite significantly. Some of the best designers in the world were on that team, including Dave. Cool. But yeah, that's the 3D view.
Yeah. And
I can just hit 2 to go back to 2D, and I can be routing, dealing with polygons, whatever. So, yeah, that's. But this cam editor is actually a pretty full-on cam tool. No one really uses it because they leave it up to the manufacturer these days. But you can do a lot of analysis and DFM checks in here. It's got a list of rules. You can load DRC rules from the board editor as well, and do the same design rule checks in the actual cam image documents. You can look for all sorts of things. You can create a fabrication drawing from the drills. Generate outlines. You can generate route toolpaths, and it has. It also has panelization and a film wizard, so you can use this to panelize boards. Although there is an easier way to do that in the main PCB editor.
Yeah, we should talk about that on a show where we've got the whole show and start off with panelization and some other. I had a couple of topics like that. Well,
we could, but then all the KiCad users are like, yeah, this episode's not for me. I mean, I don't want to alienate anyone. You know what I'm saying, Bill? What it might be better is to get someone on like Johan, who really knows how to drive KiCad, and maybe another person who really, like a friend from Autodesk who really knows how to drive Fusion 360 and Eagle, Jorge, and we could have a group show where we can compare notes on how different tools do a few different interesting things. And not to say any one tool is superior to others. Of course, they're all
different. Yeah.
I mean, Altium is inexpensive. It's not nearly as expensive as Cadence or Mentor, but it is a pro-grade commercial tool, and there's a reason for that. There's a lot of technology in it, and it can take a long time to become a master, but it's actually extremely powerful. But just for the basic things that we know every tool can do, we could do some quick comparisons. That would be fun. Yeah, Jonathan, and others. It'd be interesting to see, like, how do you make a footprint?
Right.
From a data sheet. I mean, that in itself would take a whole hour to compare even 2 tools to each other.
Right.
So.
Right.
Yeah.
Three-way PCB off sounds fun, Jonathan mentioned.
Cool.
Yep.
Well, for those who are here in the United States, I think it's a federal public holiday weekend. Is that correct, Bill? Is it a public holiday for you too?
Yeah, it's Memorial Day or Labor Day. I forget which.
I think it's Labor Day on Monday here. So for those of you in the States, have a really fun and safe Labor Day weekend with lots of delicious grilling and whatever it is you want to do.
Very cool. Yeah. And will you be grilling?
Probably, because we are in a heat wave in Escondido this week. So I want to keep the heat of cooking outside the house. So I'm going to I have some steaks.
Okay.
And I will grill them outside.
Yeah, and we watch our goose and our peacock are having an alpha male competition, see who can strut the prettiest. So we just sit there and watch them going, all right. Hold up.
Hey, I wanted to just quickly scroll back. There is another question. about if the design is good, will it go for generations? Can I detect it? I'm really not sure what that means. If I can run checks in the CAM editor to see if a design will have good longevity, I don't think that's easily predictable, other than just designing it well and keeping everything well within spec.
Right.
But it made me think there is one thing about the CAM editor that's extremely useful if you're importing Gerbers from somebody else's project. And any good DFM tool that can import Gerbers should be able to do this. Like Next DFM, we've looked at that in an episode more than a year ago, but there's free DFM tools you can download from some manufacturers. And Next PCB had a really nice one, actually, that they've made as a free download called Next DFM. And they can do things like you can go in and set the layers to be transparent individually, or you can, let's see, where is it? You can isolate them. Where are the settings here? I'm right-clicking here. You can do comparisons, so you can bring two of the same Gerber if you're told this is the same thing, but you're suspicious that one of them has been modified. Right. You can bring them both in as different layers and do a compare, and it'll show you exactly all the places where the changes were made. So if your fabricator sends your Gerber file back to you because they've modified something to meet their design requirements for manufacturing, you can actually see what they've done and visually compare them, right? So that's also pretty cool. Where is it, though? I think it's in composite layers. Yeah, I think you can combine layers, and there's all sorts of stuff you can do here. What I'm looking for is there's a prep. Where the heck is preferences gone here? I think it must just be kept up in this little cog. So if I go to preferences and CAM editor, view, translucent viewing, default. But I would think I can switch between, that you can see if you make everything translucent, there's a
a dozen people just looked for their phone.
Right, so you see how the layer colors are ORed together.
Okay.
So if we have bottom and top, we get magenta. Of course, if you keep adding layers up in translucent mode, you eventually end up with white.
White,
and you can't see white with the black background. You can't see really anything. But if it's just a really good way to see things, to visually understand what the Gerber images are actually going to produce. And it's probably good design hygiene to give something like this a once over before you send it to fab.
Right.
Yep.
Right. So, okay, well, we'll see you next week then, and maybe dig some more into some of this. This is fascinating. I haven't played with the post-processing tools near as much as I have the rest of Altium.
Yeah, most people don't even hardly remember it's even there. But there's a lot that can be done with it.
Right.
I even found a basic script some years ago in the examples folder that shows how to animate a route toolpath in the CAM editor. So you can actually create route toolpaths for excising the board and cutting them out, and you can animate it to show how it's going to how it's going to be cut out, which is kind of wild.
Cool.
So anyway.
All right. Well, we'll see you next week, Ben, and we'll see everyone here next week. And we wish everybody to have a good holiday and a safe holiday.
Yes. And Dave Adams, you're right. I need to do a whole YouTube series on out jobs, but maybe just a teaser video to get people interested. And then it's just all about time. I have to do those things. for long-term business, but in the short term have to do other things to keep paying the bills, and it's pretty tough juggling the two conflicting
Yes, it is.
needs. But
speaking from experience. Yep. So, all right. We'll see you next week.
Bye. Okay. Thanks, Bill. Great seeing you again. See you, everyone. Thanks for joining us.